Hello everyone, this is Reza Wazi, and in this short lecture you are going to learn about the basics of decision trees analysis and their application in the business analytics. Decision trees is also known as classification trees. There is also a less known and less famous variation of decision trees which is called regression trees. Classification trees basically are trying to classify your target variable, and they are used only on target variables that is categorical. However, if your target variable is not categorical, it's continuous, you can still use a variation of decision trees called regression trees, which uses a variation of decision trees algorithm on continuous variables. However, when we talk about decision trees, we almost always referring to classification trees in which the target variable is categorical. Decision trees is one of the most powerful and most commonly used supervised data mining techniques that are used for predictive analysis. As you will learn, they can be used in a wide range of problems. They do not have the limitations as many other predictive analytics methodologies. They are easy to set up from the analyst perspective, and they are really easy to understand and interpret from the business perspective. And the model can be expressed as a collection of rules, a rule of thumbs, that you can generally explain it to business users and it'll be easy for them to understand. It is used much the same way for predicting and classifying categories. Again, when we are talking decision trees, we are talking about classification trees in which are used for predicting target variables that are of categorical nature. And you know the categorical nature, it means that we are going to see some discrete values for our target variable as opposed to some continuous range of values that the target variable can take on. Here are several of the advantages of decision trees over other predictive or supervised analytical methods. First of all, decision trees do not require much data preparation efforts. They are scale sensitive. It means that if you have attributes in different ranges, such as revenues that are recorded in millions of dollars and loan ages that is recorded in years, you don't have to normalize the scales, you don't have to standardize them. In many other analytical techniques, when you have this scale variation, you have to somehow normalize your data or standardize it or pay more attention to a standardized coefficients or standardized measures. But decision trees are not sensitive, so the way the algorithm works does not really care for the differences in scales. So here it saves you some time in data preparation as you don't have to worry about the scale. Also, they are not sensitive to missing values. The algorithm do not care about missing values. You can go ahead and have many missing values as long as they are not going to risk your data integrity. You can have some missing values. You don't have to worry about them. Also, decision trees algorithm is not sensitive to outliers, generally because it does not work with any sort of average as opposed to regression. You know that regression is somehow scale sensitive, so when you have scales that are varying a lot from each other, it's better to look at the standardized coefficients and pay more attention to them as opposed to regular coefficients. Missing values are not good for regressions, and regression is very sensitive to outliers because both missing values and outliers can move your average. Another good thing about decision trees is that they are not sensitive about nonlinear relationship among variables. This is something serious about linear regression and even logistic regression because both of them assume some sort of linear relationship between your independent variables and dependent variables. However, decision trees do not follow such assumptions, so it does not care about any sort of nonlinear relationship that exists among your variables. Another advantage of decision trees is that uh, it is really helpful in feature selection, in selecting those variables that affect your outcome, your target variable the most. It starts with the one that affects your target variable the most and then expands on others that are less important but still they contribute to your target variable. So it starts with the predictor and then branches out to weaker predictors. And it only includes variables that actually affect your target variable. I did not cover decision trees algorithm in this short lecture, but you can go through the book and learn a little bit more about the algorithm and how it works. But let's get more familiar with the decision trees and its structure. A decision tree model takes a form of decision flow chart, or I would say that it looks like an inverted tree, where you can see the attributes or the independent variables in each node. So each node represents one attribute or one independent variable that has an effect on classification or on predicting of your target variable. And you will see leaves or a leaf at the end of the path for each of these branches. And a leaf is where a prediction is made about the target variable based on the conditions that the path from the top of the tree or from the stem of the tree will imply. Also, you can follow the path and come up with some rule of thumbs of how these attributes, how your independent variables would affect your outcome or target variable. However, as good as decision trees are, they face a very big problem, and that's called overfit. Overfitting happens when a model tries to memorize the training dataset instead of trying to generalize, trying to learn and generalize from it. So when you have an overfit model, it does really well on your training dataset. And if you are trying to evaluate the model using cross validation, an overfit model does really good because you are using a part of your training dataset to evaluate your model. But when it comes to real world data, when it comes to unseen data or your scoring data, an overfitted model does not do good because it just memorize what happened in training data instead of learning and generalizing from the trends that is taking place in your training data. Generally, you have two ways of dealing with overfitting, and these are pre-pruning and the pruning or post-pruning. Pre-pruning are techniques that deal with the controlling the growth of your tree. Generally, the trees that are very large, they're overfitted trees. So you don't want to have very large or complicated trees with a lot of levels. So how you can control the growth of your tree? There are three major ways to control the growth of your tree. One is through increasing the minimum information gain. Information gain is the basic idea that is used in decision tree, and it's the basic idea that is used for splitting or creating branches in your decision tree. As you increase the minimum information gain, you are giving your algorithm less chance to branch out and you're making it to generalize more. Another way is to limit the maximal pass or the maximum pass or how large your tree can get. So when you limit that, you are not giving the algorithm the permission to grow as long or as much as it wants. Another one is increasing the minimum amount or minimum membership that is needed for a split. So you would say instead of having at least two members for each branch, I would require the algorithm to have at least 4 or 5 members per each branch before it can split. So using these parameters, these algorithm parameters, you can control the growth of your tree and make sure that your tree do not overgrown and do not become overfit. Another strategy is to use post pruning. Post pruning, or in short pruning, may sometimes be a better option because it will not miss any small but potentially significant relationship between attributes that may exist in your dataset. It allows tree to reach maximum depths, then starts pruning, then starts cutting off branches that do not contribute to our understanding much. However, it overloads your CPU, it introduces new computational tasks. So if you're concerned about the amount of data that is being analyzed and the amount of time that is being taken to generate the tree, post pruning may not be your best option. But with today's computational technology, you should not really have problem performing post pruning to your decision tree. So this concludes the short lecture on decision tree. Again, how the algorithm for decision trees works is out of the scope of this lecture. Your book gives some details of how the algorithm works, but not really that much details about the mathematical process or the mathematical theory behind it. But you can go ahead and read it to gain a little bit more understanding about how the algorithm works. Bottom line, it's easy to work with and it's really easy to understand and convey that meaning, what they mean to your business people.